Yes, so today we'll be talking about like real-time analytics with Pinot. So I am an engineer at StarTree. Mostly I've been working on like the upserts and the query engine part of the Pinot. And before that, I've been like contributing to Pinot since like 2020 or 2021. And like writing the JDBC driver, S3 support, and other like Kinesis support and other stuff like that. Yeah. So what is like, first let's focus on like what is the use case of Apache Pinot. So Apache Pinot is like real-time, low latency analytical database. So what do I mean by that? Like first of all, like it's an OLAP database. It's not an OLTP database. So a use case for OLAP database is something like you want to aggregate like last 6 months of booking data in an e-commerce app, or like you want to analyze the clusters of users who are doing your booking in like last week or something. While OLTP is something like you want to check the status of the booking of some user ID A or B. So Pinot is meant to do like heavy queries on a large like span of data. While low latency, I mean is that like general expectation of OLAP databases is that you run a heavy query and you'll get results in like 1 second, 2 seconds, or even it can take up to a minute. Because generally OLAP databases have to transfer a lot of data from S3 or sources like that. And like that presents a lot of overhead. What Pinot excels is in that like it can provide you the latencies at the query time of the OLTP databases while being OLAP. And the second is the real-time aspect of it. So we allow users to query data like which is coming via the streams, not just which is stored in the S3. So if you have data systems like Kafka, Kinesis, Pulsar, you can simply like plug it into Pinot, and like within milliseconds of publishing some data, it will be available for querying. We don't do any batching or anything. As soon as we read the record, it's available for querying to the end user. And like that's what makes Pinot like unique in its offering. Yep. So initially Pinot, yeah. So initially Pinot was developed at LinkedIn. So the primary use case like was you see or whenever you go to the LinkedIn profile page, you see who's viewed my profile section. And there are like a lot of other stats that are present on LinkedIn, especially for the recruiters. So you want something that can calculate all these stats when the user is querying them, rather than like having some pre-aggregated data, which is old, like was computed like 1 day before and is like cached somewhere. So this is where like Pinot was basically designed to do. LinkedIn has like hundreds of millions of users that can make real-time analytics query. So, and like this can only be done like with a system like Pinot, which can give you the results in milliseconds. Other use cases can be like, for example, you have like Grofers or you have like Uber Eats, where you want to show a restaurant manager like how many bookings have been done, like how many orders have been placed, where in which areas are our drivers located like right now. So all of this, rather than depending on the OLTP databases, you can simply plug in Pinot and like get all of those results like as quick as possible. So Pinot like currently is being used by like a lot of companies. We have like around 4,500 stars on GitHub. Like we have like a lot of Slack users. Our OSS community is really active. You can any day like ping to share your like grievances or anything, or if you want to chat about anything on Pinot, like you can just ping on us our open source Slack, and like you will get any one of the core members in like within minutes to answer your queries. So I'll touch briefly on the architecture of the Pinot. So Pinot, like the main design principle of Pinot is separation of responsibilities. So we have like multiple components. The major one being the controller, broker, and the servers. So servers are the component where you have to store all of your data, whatever like data is being consumed, and whatever you want to make it available for querying is present in the servers. And servers are the one that handle the query of a table partition rather than the whole table. And all of that data is stored, the Pinot stores all of that data in the immutable tar files called segments. So servers are like horizontally as well as vertically scalable. So based on your like the data needs, and like they are the most heavily used component of the Pinot cluster. Then like there comes the controller. So the controller serves as the like basically coordinator of the whole cluster. It each and every component of Pinot knows only about itself. It has no information of what the other components are doing. Only controller knows what task should be assigned to each server, broker, or anything else. What do I mean by task? For example, you want to start ingestion from Kafka for some table. So which of these servers should actually ingest the data? That will be decided by the controller. And in case you want to scale up your servers, so from 3 to 5. So how do we know like which data should go to the new servers and which should remain in the old? So that is again like done by the controller. And how does controller gain that information? It's via Zookeeper. So all of these are all of the components in the Pinot like update their state to the Zookeeper, and controller uses Helix to basically keep track of everything, every state of every machine in the cluster. And like on basis of that, like it takes the decision on how to assign the data and like do like basically ensure that your data is always available. The broker is where like your user, whenever user fires a query, it goes to the broker. Broker is like really simple. What it does is that you have a SQL query. It will simply transform that SQL query into a tree which is understandable by Pinot. And like it will then send that query to the appropriate servers. So, and those servers will like actually run that query because they have the data to run that query, and like they will return results back to the broker. The broker will aggregate all those results and like it will return them back to the user. So Minion is like was a new component that we only recently introduced. So the thing was like there are a lot of ad hoc tasks which happen in Pinot servers. Some of that task could be like basically merging some old segments together because you don't want duplicate data like across the servers, or you don't want like a lot of files like basically polluting your directories and stuff like that. So what we did was like all of these tasks usually ran like on the basis of cron or something, and it basically like didn't allow us to, we were basically limited by the number of servers to run these tasks. So if you had 3 servers but you had a cron job which triggered on like once per weekend, so you were limited by just those 3 servers to complete the task of that cron, which can result in like that cron job running on for like hours or even days. So what we did instead was like we again separated out that completely in the form of minions. And in the minions, we have this auto scaling feature. So you can like keep minion at 1 or 2. And like whenever that cron job runs, only minions scale at that time. Your cron is completed and like the minions scale down again. The deep store is just the like the S3 or any other distributed file system. So there, in the default implementation of Pinot, we just keep the segments at the backup. The data is served by the servers only because to ensure the fast latencies. But the segments are always available in the deep store so that you can basically easily transfer them across servers, and like there's to ensure that there is never a data loss in a Pinot cluster even if a server goes down. So there are like a lot of differentiators in Pinot compared to the other OLAP databases. The first one being the number of indexes we support. So we don't have just simple inverted indexes, which are like, for example, you fire a query, select all from booking table where user ID is equal to ABC. So that is on user ID, generally people create an index and like they expect that you can easily figure out like where does the user ABC lie in the data, and like you quickly return the results. But we support a lot more indexes on top of it. Yeah. So we have like support for range indexes as well. So in the range index, you can do queries like where timestamp A is greater than equal to T1 and less than equal to T2. We have JSON index where we allow users to simply, rather than even breaking down JSON into multiple table columns, you can directly ingest the raw JSON itself in the Pinot. And even with that, like you will be able to query the individual key and value of that JSON at the same latencies as you would like if you had like done broken that JSON down into multiple tables and columns. Like that presents an ease of access to the user so that they don't have to bother with creating like whole schema to ingest some data. Then we have like text indexes, which is like something like Elasticsearch offers. So in the text indexes, we basically allow users to search where string is like ABC and similar queries. And then we have like aggregation optimization. So the aggregation optimizations I'll cover in the next slide. The geo index is basically for the use cases like Uber, where you have to track which cab is at which location. So you actually need some way to quickly like get the count of like cabs at location, which can be identified by some polygon of coordinates. So we support like I think H3, which is Uber's implementation. And so you can easily query how many cabs are located in a particular H3 cell. Yeah. Then we have like approximate like count operations so that users don't have to. Doing an exact count, especially the count distinct, is sometimes extremely heavy. So we support like approximate versions of those. So you can get 99.99 percentile results while like without like waiting for all the data to come together for a particularly indistinct operations to proceed. The next thing we offer is the StarTree index. So StarTree index is like you want to perform some heavy aggregation queries always on Pinot. Like select some clicks from table where country is US and browser is Chrome. Now you can do two things. Either you can wait for Pinot to complete that query. And to complete that query, it will have to basically search for all the rows using inverted index where that data lies and then do the summation of all these rows. Or you can simply create a StarTree index. What StarTree index does is that like it allows, it's basically a form of pre-aggregation during the ingestion time itself. So when you are ingesting the data, you can mention, I will perform the query where I will gather the sum of this column. And the dimensions I want is country and browser. So it will create a sort of a tree structure and it will pre-aggregate some of the data for which it knows like it won't see something new. And like there will be some amount of data which will not be pre-aggregated. So when this query actually runs, what happens is that like we simply fetch the pre-aggregated data from the index, and whatever we don't have available, we simply aggregate it at like the real time and like return the correct results to the user. So this allows like this makes the aggregation queries insanely fast because you have reduced the like the CPU time thing to basically do the aggregation to just a simple lookup. Yeah, so StarTree index basically is just like, if you think in simplest terms, it's just like you can basically index like each and everything and basically depend on the index to do aggregation in the real time, or you can pre-aggregate each and everything, which will increase your space to create that index. So StarTree index just lies in between these two, and you can easily configure the StarTree index to determine like how much like data do you want to be pre-aggregated to save up on space, and at the same time like providing the appropriate like latency benefits. The next thing we offer is the upserts. So upserts are like basically in the OLAP databases, like most don't support upserts because by nature the OLAP data is immutable. So in Pinot also we have the same implementation. The data is fundamentally immutable in nature, but we still support upserts via like a metadata. Basically, we keep the metadata of where the particular like where is the latest data located for a particular primary key. And like the upserts like are supported like on real-time tables. So as if you have data coming in via Kafka, so for example, you have some order stream coming for each where you have some user and what is the status of that user in e-commerce site, if he has clicked add to cart, if he has actually ordered something, if he's on search page. So you can simply keep track of everything via the upsert, and like upsert will always return you the latest result, like what is the state of this user, and like you don't have to basically do all this during the query time. Otherwise, you'll have to write a whole long OLAP query to basically dedupe the data and like get the latest state. But Pinot does that by default during the ingestion. The next is the join support. So the joins, like we support two types of joins. One is the lookup join. So in the lookup join, what we do is that like we allow users to create dimension tables. And these dimension tables are located in the same servers where your data is located, so that you don't have to do any like cross-server communication during the join queries. It saves us a lot of latency at the like cost of like extra space. And like the next thing we offer is the full SQL join. Next. Yeah. So the full SQL join is like when this was only recently introduced, and like we allow like basically all servers to communicate to each other. And like if you want to join table A from table B, and like the servers communicate with each other, shuffle the data together, and like it will return you the final results. Like earlier in the earlier implementations of Pinot, we didn't allow servers to communicate to each other. They were like independent component. But now with this full SQL implementation, the servers also like are able to shuffle data between them. Yeah. Next. Cool. Yeah, so you can try out Pinot at like pinot.apache.org. We also offer free trial of StarTree. You can go visit our website to try that. And you can always join us like where each of our members is like active, and like you receive response within minutes. Yeah. Thank you.